Hello, Algebra 2 folks, and welcome to Evaluating Functions and Understanding the Graph of a Function. Okay, we're going to start out by talking about the learning targets like we do every day. So the learning targets are: I can read functions written in function notation, I can evaluate functions accurately, and I can determine if a relation of a graph represents a function. Okay, so let's first look at reading functions that are written in function notation. So often function rules are written in y equals, like y equals 3x plus 4 or y equals 2x. With function notation, what we're going to do is we're going to take that y and replace it with the name for the function. Because when every function is named y, how do we know which one's which? Okay, so we want to name them differently so we can keep track of them better. So the first thing we're going to talk about is what the f means. And the f in this is the name of the function. So it tells us that we are talking about the function with the name f for Frankie or Freddie, okay, or Francis, okay? So f is the name of the function. X is the input value, the values that we're going to put into the rule, whether it be 1, 2, 3, 4, 5, or negative 10. Okay, those are our input values. 3x plus 4 is the rule. What rule do we need? Well, we need a rule so that we know when we plug in x, what our output's going to be. And then if we look at f and the x together, basically what we're saying is the value of f at x. So we know we're talking about f being the function and x being the input. And another way we can say that is f of x. So f of x, that whole thing, is what we replace y. We're taking out the y, and replacing it with f of x. Okay? So now we're going to talk about the second learning target, which is evaluating the function rules. So we're going to look at example A. F of x is equal to negative 3x plus 7. So f is the name of the function, x is the inputs, and the rule is negative 3x plus 7. And now I want you to evaluate that when x is negative 2. So what we're going to do is we're going to say that we can plug in the negative 2 in for the x, because negative 2 is our input. So this is the name of the function. And the name of the function is f, and the input that we're going to use is negative 2. This never changes. We never do anything with the left side. It always stays f of negative 2. Now with the right side, what I know is that negative 2 is my input value. And if I know it's my input value, everywhere I see an x, I can plug in a negative 2. So negative 3 times negative 2 plus 7. Okay, f of negative 2 stays. That's the name of the function with the input we're using. Negative 3 times negative 2 is 6 plus 7, and that would be f of negative 2 is equal to 13. So what this says is that my x value is negative 2, and when I plug in a negative 2, I get an output of 13. So I get a y value of 13. Okay, or I get an f of negative 2 value of 13. F of x is 13. Okay, so then if I use g of x, and I still want to input that negative 2, I would say now I'm talking about a different function whose name is g, not f. So instead of Freddie or Frankie or Francis, now it's Georgina, Georgia, whatever you want to call g. Okay, so g of negative 2 is equal to, okay, when I plug in the negative 2 in for everywhere I see x, I need to use parentheses, because when we substitute in, we always use parentheses. Okay, negative 2 squared is the same thing as saying negative 2 times negative 2, which is 4, minus 4, subtract 10. 4 subtract 4 is 0. minus 10 is negative 10. So g of negative 2 is negative 10. That also means that with the input value of negative 2 as my x, my output will be negative 10. So I can write it like this, or I can write it like an ordered pair. One of the two is the correct way to answer that problem. Okay, what if I look at it another way? So now I have f of x equals negative 3x plus 7. So that's the same function we're working with. And the g of x is x squared plus 2x minus 10, which is again the same function. But now my directions say find f of negative 4. Okay, well now this is telling me that when I see the function that's called f, I would input negative 4. So everywhere I see an x, I'm going to plug in a negative 4. So f of negative 4 is equal to 12 plus 7. So f of negative 4 is equal to 19. Or again, I can say that every time I input negative 4, I get the output of 19. Okay? Over here on the right side, I want to find g of negative 1. That means in the g function, not the f function, not a different function, but the one that's called a g, you will insert a negative 1 into your input. So g of negative 1 is equal to negative 1 squared, remember parentheses, plus 2 times negative 1, subtract 10. G of negative 1 is equal to 1 minus 2 minus 10. And that would be 1 subtract 2 is negative 1 minus 10 is negative 11. Or if I want to write it in ordered pair form, I could say the input of negative 1 will give us an output of 11. Okay? So in either case, that is what those mean when we are evaluating. All right, now let's talk about the last ICANN, which has to do with graphs of a function. So now I want you to consider the two graphs that I'm going to put up on the screen in a second. And we gathered some information about people and their heights, and we made two graphs. Now you don't need to write this down, but I just want you to pay attention. So here are the two graphs that we made. And in the first graph, we said the name of the person is considered the x and their height is considered a y. Now if you notice, we've got Joe, Amy, Bill, Ryan, and Tom, and they all have an individual height. So every single person has their own height. But if we look at the second graph on the right-hand side, we made the height the x value and the name the y value. Okay, now if we were to compare these two graphs, they still have the same information, but one of them represents a function and one of them doesn't. Now remember what it means to be a function. Yesterday we talked about that a function, every x value has a unique y. So Joey has a unique y, Amy has a unique y, Bill has a unique y, and so on. So if I'm looking at the left-hand side graph, I can say the left-hand graph is a function. Every x value has only one y. If we look at the right-hand side, if you notice, our height is in the bottom and the names are in the y. And if you notice, if we go to the height of 5, two people have the same height. And so that would represent not a function because every x doesn't have a unique y. So this would not be a function. The x value of 5 has two different y values. So knowing this concept and being able to visualize these two graphs, we're going to be able to determine if a graph is a function just by looking at the graph. And we're going to use this cool thing called the vertical line test. So now you need to put this in your notes. Make sure this one is in your notes. The vertical line test is tells us a relation is a function if a vertical line drawn through its graph passes through only one point at every given point. Okay, so the vertical line test helps us to determine if a relation is a function. Okay, and we use the vertical line. Vertical means up and down. Remember, I'm vertically challenged. That means I'm short. So if you're having trouble, that's a good way to remember it. Okay, so vertical, up and down. So we're going to take our pencil and move it from the left side of the graph to the right. And if it crosses more than one point at one time, it is not a function. Okay, so this is what we use for a vertical line test. All right, now I'm going to use the vertical line test on that right-hand side graph that we were talking about where I said was not a function. So I'm going to take my pencil. See my pencil? You don't need to write this down, just pay attention. And I'm going to move my pencil across the paper. And I'm going to keep moving it across the paper. And then when you notice, when it's over those 2 points, it's over those 2 points at the same time, would this graph be a function? And I say, no, it would not be a function because those 2 points line up vertically at the same time. Okay, let's try a couple more. Let's try the vertical line test on this graph. So I take my pencil. I'm going to say, there's a point. Well, there was a point, and I went past all the points. Did my pencil touch 2 points at the exact same time? And I'm going to say, no, they didn't. So therefore, it passed the test. So yes, it is a function. Okay? If it touches 2 points at the exact same time, then it fails. Therefore, it's not a function. Okay, let's try another one. Here I've got kind of an oval going on. I'm going to take my pencil, slide it over. Notice there's a point. Slide it over. Oh yeah, see, when I went through those 2 points, when I went through those 2 points, they went through 2 points at the same time all the time almost through this whole graph. So no, it is not a function. Okay, and that is all I have. So those 3 learning targets, understanding function notation, understanding how to evaluate, and then being able to use the vertical line test to determine if a graph is a function. So that's all I have, and we'll see you tomorrow and practice this some more.